impressive that they were all similar to the effect size of somebody having a bleed forward heel. So that really gave us foundation for going after this link between the eyes and brain. So now we're going to move on to the visual function and Alzheimer's disease. So on that study, we just kind of reviewed that they all get enrolled, they get cognitive testing, but outside of that, they have gone through many eye evaluation because they were throughout their disease, throughout their history. So we wanted to leverage that. We develop our in-house natural language processing system, but then we also went further and then we extracted all the clinical data. We're still in the process of it, but you can see that on the paper chart, this participant was actually seen at the age of 29. Imagine all the handwriting that we had to decipher. So we included about 4,500 people, and then we divided into the eyes that develop dementia, Alzheimer's disease, and then the dementia. So we had about almost 250,000 of encounter data. So this is the work of R&D. So I'm looking at the real time, the fluctuations of each individual eye that is going from some as early as the age of 25, but then you can kind of see that the eyes that did not develop dementia maintain good vision, as opposed to Alzheimer's disease dementia and non-AD dementia, which is mainly the vascular dementia and other dementia such as Lewy bodies. If you look at the summarizing figure onto the right, you can see that
나가는 거야.
Trajectories. I'm guessing some of them probably developed AMD, and maybe that's the reason. And also maybe the reason they didn't get cataract surgery is maybe the surgeon thought their vision was already too severely impaired by the AMD. I mean, could that be part of it? I know you brought it to focus this challenge of explainability with this kind of data, but do you think those are possibilities?
yes, definitely. So when we did look at the Cataract Surgery Association, we did control for those known eye diseases that were connected. At least that was one part that we could adjust because there would be compounding effect. And then the first question was, could that be, in terms of the drug on the visual acuity, could that be somewhat explained by eye diseases? Absolutely, and I think that is the reason why the actual the intersection point between
the industry for AI, IADI. Please.
Thank you so much for the opportunity to be here today with Cecilia. It's a rare honor that we get invited to the same conference together, so I appreciate that. These are my financial disclosures. So I want to spend a little bit of time to tell you a little bit about the Bridge to AI program that Cecilia and I are working very hard on. This is a new initiative from the NIH on models in medicine, cell maps for the human body. The second one is called VOICE as a biomarker predictive of different health states. The third is our project called Salutogenesis or AI Ready. And the fourth is getting data from critical care settings in the ICU to predict mortality. So I'm going to tell you a little bit more about our project, and actually Cecilia is going to tell you a lot more about this tomorrow, so I'll kind of go over this quickly. But the goal of our data set is to build a multimodal data set to study type 2 diabetes. And we're trying to construct this data set in a balanced way to try to make AI models that are trained with it fair and unbiased. There's many different aspects and domains of data that we're collecting. So we spent a lot of time trying to harmonize this data in a way that makes it easy for other people to use. And so for the retinal imaging component, basically everything is being transformed and harmonized into DICOM. In terms of the imaging devices, types and devices that we have, it includes many different forms of two-dimensional retinal imaging and OCT, OCTA, and FLIO. But most importantly, we have collected devices from multiple manufacturers, and we've put similar protocols, and we're asking all the participants to go through all of them. This is our imaging checklist that shows all the different protocols we have, where every participant is moved between each of the devices and imaged within minutes of each other. And one of the major reasons why we're doing this is to make it so that AI models are not hopefully tied to a single device in the future. That they could be trained across this entire data set and be generalizable to multiple devices